This is question 14 from section 3.10 related rates. A piston is seated at the top of a cylindrical chamber with radius 5 centimeters when it starts moving into the chamber at a constant speed of 3 centimeters per second. What is the rate of change of the volume of the cylinder when the piston is 2 centimeters from the base of the chamber? Well, the first thing that we need to do, as with any other related rates problem, is to find an equation that includes all the variables given in the problem, that relates all the variables given in the problem. And which is fairly easy in this question because it asks us what is the rate of change of the volume of the cylinder, and we know that volume of a cylinder V is equal to pi r squared h. Now we realize that the question also gives us r. It tells us radius 5 centimeters, so r is equal to 5 centimeters. Therefore r squared is equal to 5 centimeters squared, which is 25 centimeters squared. Now the reason I'm writing centimeters squared is so our units are consistent at the end. However, when I plug this into this equation, I'm not going to include the centimeters squared just for the sake of cleanliness. So instead of writing v equals pi r squared h, now we can say v is equal to 25 pi h. And now what we want to do is we want to take the derivative of both sides with respect to time. So dv dt, the derivative of volume with respect to time, is equal to, now this is 25 pi times h. It is a product, so we need to realize that we must apply the product rule. Apply the product rule. So once we apply the product rule, we'll get the derivative of 25 pi in terms of time times h plus the derivative of h in terms of time dh dt times 25 pi. Now from very basic differentiation knowledge, we know that the derivative of any constant is equal to 0. 25 is a constant, pi is a constant, therefore 25 pi is also a constant. So all we get is 0 times h plus dh dt times 25 pi. 0 times h, or 0 times anything for that matter, is 0. So what we're left with is dh dt times 25 pi. Now, believe it or not, the question actually gives us dh dt. It says that the piston, it is moving at a constant speed of 3 centimeters per second. Now, dh dt is really just the rate of change of the height in terms of time, which is exactly this. The piston is moving into the chamber at a rate of 3 centimeters per second. However, the question tells us that it's moving into the chamber. So if we were to draw it out, if this were to be the chamber, in order for the piston to be moving into the chamber, it would have to be on a downward stroke. Therefore, the height over here, height h, would be decreasing, meaning that the rate of change of height in terms of time would be negative. So instead of plugging in 3, we have to make sure we plug in negative 3. And the question also asks for the rate of change of volume of the cylinder when the piston is 2 centimeters from the base of the chamber. However, this information isn't very important because the speed of the piston, the rate of change of the height of the piston in terms of time, is constant no matter where the piston is. It's always moving at a speed of 3 centimeters per second. Whether it's 2 centimeters from the base, whether it's more or less, it's always moving at 3 centimeters per second. However, it's moving downwards, so we put in the negative 3. That's done. So now we just put in the 25 pi. And once we multiply this out, we get negative 75 pi. Now, in terms of units, because we can't just leave our final solution as negative 75 pi, we have to have units for this. So we have our units for r squared, which was centimeters squared. And our units for the derivative of height, or the rate of change of height with respect to time, is given in the question as centimeters per second. So centimeters squared times centimeters per second, you're left with centimeters cubed per second. Therefore, our final answer with our units is negative 75 pi centimeters cubed per second. And again, how we found this final answer was we took the question, found an equation that relates all the variables in the problem, then we differentiated implicitly with respect to time on both sides, and we ended up with the rate of change of the volume of the cylinder being negative 75 pi centimeters cubed per second.